The Starship touches down on ochre soil. Flags snap in a thin wind. Somewhere in a rendered control room, people cheer.
Signal is stable.
That is the image you have been sold, and it is beautiful. Now look at what the sensors have actually recorded on that same soil the last time a rover measured it. Radiation doses that would exceed a career limit inside a single stay. Perchlorate salts in the dust at concentrations toxic to the human thyroid at every step. A single planet-wide dust storm that swallowed the entire globe for months and blotted out the sun. There is no colony in that image. There is a test subject in a pressure suit, standing on a chemical desert under a sky that is quietly killing him. Every timeline you have ever heard was written before the real data came back. The data came back. It says something else entirely. Here is what should bother you first. Every colonization timeline you have heard, 2026, 2029, 2033, 2040, was written on a marketing schedule, not a physics schedule. Each one has slipped. Each one will slip again. And the reason has almost nothing to do with rockets. The rockets are, for the first time in history, the easy part. Starship will fly. Falcon flew. Saturn V flew almost 60 years ago. We know how to throw mass off this planet. If getting to Mars were the bottleneck, we would already be arguing about which crew goes first. The bottleneck is staying alive once you are there. Before I go further, be honest with yourself for a second. When you heard someone say we would have a city on Mars by 2050, did you actually believe it, or did you want to believe it? The rest of this video sits inside that difference. Because in the last 15 years, every measurement has made the problem worse. Curiosity's radiation instrument showed surface doses overlapping with career limits. Soil analysis confirmed perchlorate everywhere at levels regulated in parts per billion on Earth. MAVEN confirmed the atmosphere is still bleeding into space with no magnetic field to hold it. A single dust storm in 2018 killed opportunity and would have trapped any crew for months. None of these are secrets. They are quietly absorbed into mission planning documents while missing from the public renders. I am not saying exploration should stop. I am not saying the engineers are lying. The scientists are the reason we know how bad it is. The problem is the science succeeded and the marketing did not catch up. Here is the thesis of everything that follows. Getting to Mars is a solved category of problem. Staying on Mars is not. And the gap between those two things is not a scheduling gap. It is a species gap. The first person to stand on Mars will not be a colonist. They will be a test subject. Their bones will be the experiment. Their offspring, if there are any, will be the experiment continued past the point where it can be aborted. The phrase, colonize Mars, is not a schedule problem. It is a category error. A colony implies self-sufficiency. A colony implies you can lose contact with home and still survive. None of those conditions can be met with anything we know how to build. The problem is not getting there. Everything we have learned in the last 15 years has made staying harder, not easier. That is the thesis. Now let me prove it. The public version of Mars colonization is not one story. It is 3 separate stories quietly stitched together, and none of the 3, on their own, actually promises what the composite implies. The first story is SpaceX. Rockets landing on drone ships, starships stacking taller than the Statue of Liberty. A launch cadence that would have looked impossible 10 years ago. That story is real. It is also a story about getting mass to orbit, not a story about human survival on another planet. The second story is NASA. Perseverance sampling ancient river deltas, Ingenuity flying in Martian air, sample return architecture inching forward. That story is real too. It is a story about robotic science, not about colonies. Read NASA's own Moon to Mars planning documents carefully, and you will notice a phrase repeated with quiet precision. Mars is a horizon goal. Horizon, in agency language, does not mean soon. It means visible, distant, and not on the current budget line. The third story is Hollywood. The Martian, Interstellar, countless renders of glass-domed cities glowing at sunset. That story is fiction, and everyone knows it is fiction, and yet its imagery keeps leaking into the other two. Stitch the three together, and you get something none of them actually promises. A cinematic city arriving on a SpaceX schedule, blessed by NASA science. That composite is what most people believe. That composite is not in any real planning document. Where are you watching from tonight?
Whatever room you are in, the air above your head is doing something Mars cannot.
It is holding pressure. It is filtering radiation. It is buffering temperature. The version of the Mars story you have absorbed quietly assumed all of that could be rebuilt. It cannot. Not yet. Not at scale. Look at the timeline slippage itself. Wernher von Braun proposed a crewed Mars mission in the 1950s. Every decade since has produced a new, confident date, and every date has slipped by roughly the length of the promise. NASA quietly pivoted from Journey to Mars branding in the 2010s to Artemis and the Moon. SpaceX's crewed Mars date has moved from 2024 to 2026 to 2029 to unspecified. None of that is failure. It is the physics asserting itself against the marketing. A generation is planning careers, investments, and emotional lives around a destination that has not been engineered. That is the human cost of the composite story. Not death, not disaster, just quiet misdirection. To understand why the timeline keeps sliding, we have to stop looking at the rockets and start looking at the planet itself. Start with the air, because everything else fails through it. The Martian atmosphere averages about 610 pascals of surface pressure. Earth at sea level is 101,325 pascals. That is not thin air. That is roughly 0.6% of what you are breathing right now. To find a comparable pressure on Earth, you have to climb to about 35 kilometers, higher than any commercial aircraft flies, higher than most weather balloons, into a layer of atmosphere so hostile that pilots refer to it as near space. That is the ground level of Mars. There is a threshold in aerospace medicine called the Armstrong limit. Above it, at pressures below about 6,000 pascals, the water in your body starts to boil at body temperature. Not because it is hot, because the pressure is too low to hold liquid together. Exposed saliva vaporizes on the tongue. Tears boil on the eye. Blood, protected by the skin, does not immediately erupt, but the tissues around it swell violently as dissolved gases expand. Mars is 10 times below the Armstrong limit, so an unprotected human on the Martian surface does not suffocate first. They swell first, then they suffocate, then they freeze. The sequence takes seconds. Now translate that into what a colony has to be. Every structure is a pressure vessel. Every door is an airlock. Every wall is a barrier against vacuum. Every crack is a bleed. A slow leak on Earth is a maintenance ticket. A slow leak on Mars is a countdown to unconsciousness for everyone inside. This is why every serious Mars habitat concept looks like a can. Not a house, a can. And the can has to be shielded, sealed, monitored and pressurized continuously for as long as anyone lives there. Now consider terraforming, the popular fantasy of thickening the atmosphere until people can walk outside. Run the math on the CO2 budget. Every credible study finds there is not enough accessible carbon dioxide locked in Mars's polar caps and regolith to produce breathable pressure, even if all of it were released. And MAVEN data shows that whatever atmosphere you did build would keep bleeding into space, because Mars has no global magnetic field to hold it. You would be filling a bucket with a hole in the bottom for centuries, at a cost no civilization has ever spent. The domed city is not aspirational. It is the only physically possible configuration. And every failure mode of that dome is catastrophic. And even inside that pressure vessel, something is coming through the walls. What is coming through the walls is radiation. Not the kind that sets off a Geiger counter next to a hospital scanner. The kind that arrives from deep space at nearly the speed of light, in the form of high-energy protons and heavy atomic nuclei, and passes through thin aluminium hulls the way sunlight passes through window glass. There are two sources: galactic cosmic rays produced by supernovae and pulsars far outside the solar system, arriving in a constant, slow drizzle, and solar particle events produced by the sun itself, arriving in violent bursts that can deliver a lethal dose in hours. On Earth, both are stopped. First, by the planet's global magnetic field, which deflects most of the incoming charged particles. Then, by roughly 10 metric tons of atmosphere sitting above every square meter of ground, which absorbs whatever gets through. You have lived your entire life inside that shielding without noticing it. Every human who has ever existed has. Mars has almost none of it. No global magnetic field, an atmosphere less than 1% of Earth's. The particles that reach the Martian surface are, for practical purposes, deep space radiation lightly filtered. The Curiosity rover has been measuring this since 2012 with an instrument called RAD. The surface dose is roughly 0.67 millisieverts per day. A round-trip mission of about 500 days on the surface, plus another year in transit, delivers a total dose in the range that NASA has historically set as a career maximum for its astronauts, in a single trip. For comparison, the International Space Station sits inside Earth's magnetosphere. Apollo crews spent days, not years, outside it. No human being has ever lived long-term in the deep space radiation environment. Mars' surface exposure is closer to that environment than to low Earth orbit. There are proposed solutions. Bury the habitat under several meters of regolith. Wrap it in water tanks. Line the walls with polyethylene. Every solution reduces to the same physical requirement: mass. Meters of mass between the crew and the sky. Mass that cannot be launched from Earth economically, only mined and stacked on site by machines that do not yet exist at scale. The buried habitat is not a colony. It is a bunker. The colonists inside it are not settlers. They are chronic radiation patients, accumulating cancer risk, central nervous system damage, and cardiovascular degradation from day one. And the radiation is only dangerous because something else is missing, something the human body was never designed to live without. The thing that is missing is gravity. Not all of it, just enough of it to matter. Mars pulls on the human body at 38% of Earth's strength. And here is what almost nobody says out loud. We have zero long-term human data on what that number does to a living body. Everything we know about human physiology in altered gravity comes from two data points: Earth at 1G and microgravity at approximately 0G aboard Skylab, Mir, the Space Shuttle, and the International Space Station. Between those 2 points is a gap of roughly 1G, and inside that gap sits every partial gravity environment humans might ever live in. the Moon at 0.16 g, Mars at 0.38 g, every asteroid, every orbital habitat, every proposed spinning station. The gap is unstudied, not lightly studied, not partially studied, unstudied. Here is what we do know from the microgravity end. Astronauts on the International Space Station lose roughly 1 to 2% of bone density per month, particularly in the load-bearing bones of the hips and spine. Muscle mass drops rapidly without deliberate resistance training. Cardiovascular deconditioning sets in within weeks. Fluid shifts toward the head, raising intracranial pressure and producing a syndrome called spaceflight-associated neuroocular syndrome, which permanently reshapes the eyeballs of long-duration crews. Now the honest question, is 38% gravity enough to prevent that? Is it 62% as damaging as microgravity? Is it 10% as damaging? 90%? The answer is that we do not know. There is no experiment. There has never been an experiment. Apollo astronauts spent days on the Moon, not years. No one has ever spent a month, let alone a year, in partial gravity. The first crew to live on Mars will be the experiment. Their skeletons will be the data. Their hearts will be the data. Their vision will be the data. And then consider what happens if children are ever born there. A child conceived in Mars gravity, gestated in Mars gravity, delivered in Mars gravity, and grown to adulthood in Mars gravity may develop a skeleton, a cardiovascular system, and a vestibular apparatus shaped for a world their parents can leave and they cannot. Colonization becomes a multi-generational biological experiment whose outcomes cannot be predicted and cannot be reversed. That is not settlement. That is speciation at low resolution in real time. And that assumes they even survive the trip to conceive them. The human body is a piece of Earth. Every cell in it evolved inside a specific pressure, a specific gravity, a specific magnetic field, a specific microbial ecosystem. Move any one of those variables far enough, and things start to drift. Move all of them at once, and the drift becomes cascade. Start with the bones. In microgravity, 1 to 2% per month. In Mars gravity, probably less, but not zero. And the cumulative loss over a 2-year surface stay could push a crew member into the fracture risk of an 80-year-old. On Mars, a broken hip is not a rehabilitation problem. It is a death sentence, because there is no way home. The muscles go faster. Sarcopenia in months. Astronauts return from the space station unable to walk unaided. Mars crews would return, if they returned at all, from a longer exposure with lower gravity in between. Then the eyes. Spaceflight-associated neuroocular syndrome is documented in most long-duration astronauts. Flattened eyeballs, swollen optic nerves, permanent visual changes. In partial gravity, no one knows if it improves, stabilizes, or worsens over years. Then the immune system. Studies of astronauts show latent viruses reactivating in flight. Herpes simplex, Epstein-Barr, varicella zoster, all detected in shed viral particles at rates well above the ground-based population. A sealed habitat with a small crew is an ideal environment for those reactivations to spread. Then the microbiome. The bacteria that live in your gut, on your skin, in your mouth, are a functional organ, and they were shaped by an Earth environment. In a closed habitat, cut off from Earth's microbial background, that ecosystem will drift. Nobody knows toward what. Then the mind. Round-trip communication delay with Earth reaches roughly 44 minutes at maximum planetary separation. Every question, every reassurance, every decision, every argument with mission control arrives late. You are physically alone in a way no human being has ever been alone. Isolation studies from Antarctic bases and submarine crews show reliable rates of depression, insomnia, and interpersonal breakdown at durations far shorter than a Mars mission. The magnetosphere you have lived inside your whole life without noticing is stripped away. Every cell in a colonist's body is exposed to deep space radiation for the first time in the 4 billion-year history of terrestrial life. That is not the sleek, suited pioneer of the render. That is a fragile, medicated, monitored human, aging faster than their peers on Earth. And these are the problems for the ones who arrive. Most of the mass supposed to arrive with them will not. Mars and Earth do not sit still relative to each other. They orbit the Sun at different rates and only line up favorably every 26 months. That alignment is called the launch window. Miss it, and you wait 2 years and 1 month for the next one. Best case one-way transit is roughly 6 to 9 months. There is no faster route without exotic propulsion that does not yet exist. Which means that from the moment a crew leaves Earth, they are structurally out of reach. A supply failure on Mars cannot be answered from Earth in less than a year, usually 2. If the oxygen generator breaks in month 3 of the surface stay and the next resupply Starship is not on the pad, the crew waits 9 months for the launch window, 6 to 9 months for transit, then hopes the payload lands within a few kilometers of the habitat. If any step fails, they wait another 26 months. There is no evacuation. There is no lifeboat. There is no Coast Guard. This is the deepest logistical isolation any human community has ever faced. Compare this to Antarctica, the closest terrestrial analogue. McMurdo Station is resupplied by ship in the austral summer and by aircraft in emergencies. Crews can be evacuated within weeks in a medical crisis. And even Antarctica has produced psychiatric emergencies, appendicitis crises, and deaths that could not be prevented by proximity to civilization. Mars is not Antarctica. Mars is Antarctica with the ships removed and the radios delayed by 20 minutes. The proposed answer is in situ resource utilization. Mine Martian water ice, extract oxygen from the CO2 atmosphere, make rocket fuel from local carbon, build habitat components from regolith. All of it is possible in principle. Almost none of it has been demonstrated at scale. The MOXIE experiment on the Perseverance rover successfully produced oxygen from Martian air. It produced it at the rate of roughly a small tree. Enough to test the chemistry, not enough to breathe. Scaling MOXIE to keep a crew alive requires a facility that has never been built, on a planet that has never seen one. A colony that depends on Earth for pharmaceuticals, semiconductors, spare parts, or seed stock is not a colony. It is an outpost with a 2-year umbilical cord. A broken oxygen generator on Mars is not an inconvenience. It is a countdown. None of this is secret. Every agency has these numbers. So why does the public keep hearing a different story? Because the story serves people who need it told a certain way. Not through conspiracy, through incentive. And incentive shapes narrative more reliably than any coordinated deception ever could. Start with NASA. NASA's budget passes through Congress annually. Congressional enthusiasm for spaceflight rises and falls with visible ambition. A program that says Mars is close draws funding. A program that says Mars is a compounding stack of unsolved biological, radiological, and logistical problems does not. So the agency does something clever with language. Mars becomes a horizon goal. That phrase commits to nothing, funds everything, and translates into public headlines as coming soon. Then SpaceX. SpaceX is a private company with a founder who has staked his brand on Mars. The valuation of the parent operation, the recruitment of engineers, the confidence of investors, All of it rests partly on the belief that Starship is the vehicle that gets humans to Mars in a timeframe that matters. Extend the timeline honestly, and the story loses some of its gravitational pull. So the timeline stays optimistic in public, even as the internal engineering estimates drift. Then the media. Every documentary about Mars ends on hope, because hope funds the next documentary. A film that concludes Mars colonization is a category error is not commissioned. A film that concludes we are close, but there are challenges to overcome, gets made every year. Then the audience. Us. We want the story to be true. We want the horizon to be reachable. We want a species that goes somewhere. That desire is not weakness. It is one of the more admirable things about human beings. But it is also what makes the softer version of the story sell. Now the fairness clause, because it matters. I am not saying NASA is lying. I am not saying SpaceX is lying. I am not saying the documentary makers are cynical or the engineers are incompetent. Almost the opposite. The engineers are doing extraordinary work. The scientists have delivered data that would have been unimaginable a generation ago. The rovers are miracles. The rockets are miracles. What I am saying is narrower. The public narrative is calibrated to sustain enthusiasm. The physical reality is calibrated to physics. And those two calibrations have drifted apart. Every milestone you hear celebrated, a Starship landing, a rover sample, a habitat prototype in the Nevada desert, is a component. Not a colony. A component of a system that has never been assembled at scale and may not be assemblable at all. Which means the real problem is not Mars. It is what Mars is telling us about ourselves. Mars is not the problem. Mars is the diagnostic. Every barrier we have talked about is called a Mars problem in the popular framing. Radiation, partial gravity, life support closure, psychological isolation, supply chain lag. But each one, if you look at it closely, is not really about Mars at all. It is about a broader class of environment that includes Mars and includes almost everywhere else humans might want to live. Radiation is not a Mars problem. It is a deep space problem. Any long-duration mission outside Earth's magnetosphere faces the same dose accumulation. The Moon, the asteroids, orbit around Venus, a generation ship. The physics does not change because the destination changes. Partial gravity is not a Mars problem. It is a we have no habitable gravity outside Earth problem. The Moon is worse. Asteroids have almost none. Every orbital habitat that does not spin sits at 0 g. And spinning stations, which have never been built at human scale, come with their own complications of Coriolis effects and structural stress. Life support closure is not a Mars problem. Biosphere 2 on Earth, with unlimited outside support and a benign climate, could not close a life support loop for more than a few people for a few years without oxygen leaks, crop failures, and social breakdown. Mars requires a closed loop with none of those advantages. Psychology is not a Mars problem. It is a small groups in sealed environments for years problem. Every terrestrial analogue, from Antarctic winter overstations to submarine crews to mere cosmonauts, has produced documented breakdowns at durations shorter than a Mars round trip. Now the historical comparison. Apollo achieved short exposure with rescue behind it. The space station achieves long exposure with rescue behind it. Mars requires long exposure without rescue in an environment more hostile than either. There is no precedent for what a Mars mission asks, and every precedent that partially applies has revealed a limit, not a bridge, which reframes the whole story. Mars was supposed to be the first step of a multi-planet civilization. the step that proved humans could live somewhere other than Earth. If Mars is this hard, the second step, an outer solar system moon, an exoplanet, a generation ship, is not closer. It is further. Each of those environments makes every Mars problem worse. The universe is not a chain of stepping stones spaced conveniently apart. It is a very deep, very cold, very radioactive ocean, and Earth is an unusually calm island in it. So what is actually stopping us? It is not one thing, it is the shape of the answer. The shape of the answer is a stack. What is actually preventing us from colonizing Mars is not a rocket, not a budget, not a political will problem. It is a compounding stack of biological, radiological, gravitational, atmospheric, and logistical limits. Each solvable in isolation, none solved together, and all of which must be solved simultaneously for a colony to exist. The atmosphere is unbreathable, unshielding, and unfixable at scale. Every structure has to be a pressure vessel. Every crack is a bleed. The radiation is chronic, cumulative, and unmitigated, except by mass we cannot afford to launch. Every colonist is a radiation patient from day one. The gravity is unstudied, likely damaging, and possibly irreversible. Every crew is a partial gravity experiment we have never run. Every child born there is the outcome the experiment is testing. The biology is unadapted, the bones thin, the muscles waste, the eyes reshape, the immune system reactivates old infections, the microbiome drifts. The mind is more isolated than any human mind has ever been. The logistics are structural. A 2-year umbilical to Earth, no evacuation, no lifeboat. A broken oxygen generator is a countdown. And the institutional narrative is calibrated for enthusiasm, not physics. Horizon goals fund programs. Optimistic timelines fund companies. Hopeful documentaries fund next year's documentaries. And the gap between the story we hear and the story the data tells keeps widening. Now go back to the opening image. The Starship touching down on ochre soil. The flags, the cheering. What actually stands there in the real 2040 or 2050 is not a colony. It is, at best, a small crude outpost, heavily resupplied, medically monitored, radiation limited, rotated on the shortest crew stays the launch windows allow. That is not what was sold. That is what is possible. Here is the narrow hope, because it is real and it is worth saying. Robotic exploration of Mars continues to be extraordinary. Sample return will happen. Subsurface ice mapping is advancing. Long-duration habitat prototypes on the Moon may eventually unlock knowledge that changes the calculation. Mars is not impossible. It is just not imminent, and it is not what the word colony describes. The comfortable version of the Mars story ends with a flag. The honest version ends with a question. What were we actually trying to escape? And why did we assume the escape was engineering? If we can answer those two questions honestly, then the version of Mars we build, whenever we build it, might actually be worth arriving at.